Hello YouTube, welcome to Study with Cecily. This is a maths one, as you might be able to tell from my lovely poster there. Yeah, this one is on Induction and Series. Now, because of the course I'm studying, the Induction and Series that I'll be covering is all the stuff you need to know for the Further Pure 1 module taken with exam board MEI. However, even if you're not taking that, it could still be useful to you because it does cover stuff that's in a lot of topics, and MEI is one of the more comprehensive exam boards in England. Even if you're not in England, then it might still be useful to you just to help with methods and practice. So, yeah, what I'll be covering will be proof through induction, summation of a finite series, using standard results, and using the method of differences to complete a series. Yeah, that's about it. Enjoy! Okay, as I said before, this video is on induction and series. Okay. The first part of this one is the rules of working for induction. For a proof by induction, there are 4 steps. As proving, true for n equals 1. This is fairly basic. You're usually given an equation and what the answer is when n equals 1. So for a series where each term is un, you are given what the value of the equation when n equals 1. To prove that it's true, you simply have to sub it into your second equation and see if it gets the right answer, basically. And that's all you have to do. So for example, if you're given the equation un plus 1 equals 4un minus 3, and you're given u1 equals 2, and you have to prove for the equation un equals 4 to the n minus 1 plus 1. Now, to check that it's true for n equals 1, you simply sub 1 in as n. So this becomes u1 equals 4 to the 1 minus 1 plus 1 equals 0 plus 1, which is 1. So yes, that's true. Ding ding! Step 2 of induction is assuming that it's true for n equals k. So assume true for n equals k, in which case the equation would become uk equals 4 to k minus 1 plus 1. Step 3, based on an assumption, you assume true for n equals k plus 1. And for this step, you actually have to prove something. Actual maths. Yay. So for this one, is you're given this equation here, un plus 1 equals 4un minus 3. So just sub the n's in for k's, the k's in for n's. You knew what I meant. So it's uk plus 1 equals 4uk minus 3. Okay. And this is UK. So you already have an equation for UK up here, so you simply sub this equation into here. So you've got UK plus 1 equals 4k minus 1 plus 1 minus 3. And if you multiply this out, so if you know anything about how indices works, obviously 4k minus 1 times 4 is same as 4k minus 1 times 4k to the 1. As you're multiplying them, you add the indices, which in this case is 1 and k minus 1, which results in an overall indices of k, as the bases are the same. And then obviously it's just plus 4 minus 3, which goes to 4k plus 1. And as we started with k plus 1, 4 to the k is equivalent to 4 to the k minus 1. Ta-da! And step 4, conclusion. Woo! All you have to write is, so, if the result is true for n equals k, then it is true for n equals k plus 1. Since it is true for n equals 1, then, sorry, my handwriting is not that good, then it is true for n is greater than or equal to 1, and don't forget the important bit, by induction. And that's it. You're done. Woo. Okay, for this module there's, well, not really this module. For this module there is quite a bit of notation throughout the 5 chapters which are in the Further Pure one with MEI module. But for this chapter specifically, there isn't a massive amount of notation. So obviously you have, as it's a series, you have the sum of series. So Sn, which is equal to A1 plus A2 plus A3, all the way up to AN. Now, as this is a slightly fancy chapter, in a slightly fancy module, it also has some sigma notation, which you can actually find in fairly simple stuff too. That was a terrible sigma. There we go, that's a bit better. Got n to the r equals 1a of r. As this is quite a simple series, you simply put terms of the series here. The number you start with, the first one, which in this case is 1. The number you go up to, which in this case is n. See, pretty simple. And the sigma is just used to mean sum of. Yeah, that's very basic.